Okay, so this is video file 2 for a property in Claremorris for Tom Hughes. Now, I briefly, in the first video, I spoke about the different types of constructions and how you would deal with different types of constructions to reduce the amount of rising damp that you're having in the property. But now I'm going to just talk in general about the specific problems for your property. So I'll start off with the roof. And I suppose one of the questions you might have is how much of the building could we retain? And you could retain the walls. You could retain all of the walls if you want, but one of the things, and I'll talk about that later about the walls, but the roof would need to be replaced because there is settlement in the roof. It's not that the timbers are particularly rotten or anything, but there is movement in the roof, there's settlement in the roof, and because of the settlement, rainwater can now penetrate through. So you can see, let's say from this photograph, you can see the roof movement because you can see the kind of tiles of sort of, so at the chimney areas, the slates, there's the wall there, like there hasn't been much settlement or drop, but between the two chimneys, that area has dropped. So you can see there's a kind of a belly in the roof there. Now if I go on to the next page, so you can see there's a belly and there's a low point here, high point here, and then a low point here. And what's happened is there's been gaps created between the slates. Large gaps have been created between the slates because of the roof settlement and the roof movement. And driving rain will penetrate through those slates, on both sides of the chimney. And it will be difficult to solve this problem without taking off the roof and redoing the roof. So I would recommend, if you're going to be renovating it, I would recommend redoing the roof because there is a lot of driving rain penetrating around the central chimney and also around the north chimney and probably around the other chimney as well, the south chimney. And I'll show photographs of that dampness later on. So this is the north chimney. Again, you can see the kind of roof settlement. But it'd be difficult to fix that problem without actually taking the slates off. And then what I would do is put on fresh timbers and level them up and get a nice level roof. So you can create a nice, a nice flush roof so driving rain can't penetrate. And I suppose the way I would be looking at it is you've got on this extension out the back, you've got a flat roof on it. Flat roofs are prone to leaking and dampness. And my attitude would be, I suppose, well, if you're going to re-roof, if you have to re-roof this portion, then you would put a sloping roof on this and do it all when you're doing part of the renovation. Now, you may decide, depending, I suppose, on whether you like the layout of the building, you may decide to knock the extension and to rebuild the extension. But either way, I think, you would be better off, whatever you do, you're putting on a sloping roof here so that you can have a better chance of keeping the rainwater out. Now, I took the liberty of doing out a sketch when I was on site. I was a full day on site from about 9 to 6. So you'll probably, if you decide to go ahead with your renovation, you'll need to create some drawings. Now I didn't draw it up on AutoCAD, but I have a fully dimensioned sketch there. So that would be a good starting point. I did actually draw up sections for you that are and I'll send you through the drawing file just so that you have them. I wanted to draw up the sections just to show you a couple of things, but I haven't actually drawn this one in AutoCAD. This is the plan, but I just wanted to show you on the plan basically what the type of construction is for your building. So the original stone building, which is shown here by the large thick walls, that's your original stone building there, and those walls are in general about 520 thick. Now, a lot of those walls have been dry lined on the inside, but there is still, significant dampness, particularly on this part of the building. These two rooms here have been more recently renovated and they're in pretty good condition. Now, this internal wall here, that's not part of the original construction. So originally, according to Seamus was there with me a number of times on site, and according to Seamus, originally all of the internal walls were stud partition. So this wall here it's still a stud partition. That one's a stud partition. So I've just called it up there as 100 stud. I'll just kind of zoom in a little bit closer here. I'll go and zoom in to about 150. Okay. So this wall here is 105 stud. All of these walls between the bedrooms are stud work as well. But this wall here is actually poured concrete, and this was probably done back maybe sometime around the 1950s, where he wanted to Seamus's father wanted to put in an extra chimney, and basically that's what he's done. And what was popular then from the point of view of construction was to do basically pour a concrete wall. So it was shuttered in stages and it was poured. So it's basically a concrete wall. There may even be some reinforcement around this area where you've got your, let's say, your opening for your chimney. So that wall there is, that's your chimney wall. Now, and then the rear extension, that was actually built with hollow block wall. So it's not a full cavity. There's actually voids in the block, so it's hollow block wall, and that block wall is about 9 inches thick all the way around. Okay, I'll talk about that later on, but that's going to be and then your internal walls here are about 100 mil solid block work. So you have various types of walls throughout. Now, I did draw up a cross section here through your, let's say this is a cross section. So this is a cross section through, I did two cross sections. So I did a cross section through here, and I also did a cross section through the living room area or the hall area. And this area actually has quite a substantial ceiling joists, because it must have been used as a store, whereas this area doesn't. But the one thing I wanted to point out is, let's say if this is the front wall here, and there's the front door. So your rafters here, and then you have a tie at this level. Now, the ceiling, it's quite high, but the ceiling is not, it's a very, very light ceiling. Now, I couldn't go up and walk on this ceiling because the timbers are too light, and basically that ceiling is just hardboard, which is against fire regulations. Actually, you're not supposed to use hardboard. You're supposed to use plasterboard because hardboard will go on fire quicker. But I suppose back in the day, that's when this was done. And anyway, plasterboard would be too heavy for even what they've done, because these timbers here are only 50 by 50, and they're actually spanning from let's say from they're not spanning in this direction across the way, they're spanning the other direction. So these timbers here, they're of no use to us in terms of tying the roof together, if you know what I mean. Let's say what I wanted to talk about here is the front wall has moved a little bit. It's moved outward. So there's pressure from the roof here, basically, because the roof is not tied at this level here. Basically, there's pressure from this timber is putting an outward pressure on this wall, and this wall has moved out in this direction of the yellow arrow. Now, the rear wall hasn't moved because I suppose it's restrained by the extension, but this front wall has moved out. Now, it hasn't moved so much that it needs to be knocked. It's still stable and it can still be retained, but the newer type of construction, let's say when it's renovated, one of the things that you're going to have to do is you're going to have to put a proper tie at this level here. So I'll draw it in for you here just temporarily. So basically you would want to have a substantial timber tying this rafter to this rafter, okay, which would be normal on most houses. And that rafter there ties makes a triangle. Basically, it makes a stable triangle out of the roof, so that the load from the roof, instead of having a horizontal thrust, it won't have a horizontal thrust anymore. It'll all just go straight down, and it'll stop pushing the wall out. So the wall will stop moving as long as the roof is designed correctly, let's say, and it's tied properly. At the minute, let's say that tie is missing, it's not there. So that's why the wall is moving. So I'll show a photograph of that later on. You can see that the wall is moving, although it's difficult to see it. So there isn't really, let's say, there isn't enough space to create a dormer or any extra space up here, let's say. I mean, it could be used for storage, but there isn't really enough room to create a second floor from the point of view of complying with building regulations. And that was the main thing I wanted to point out here. Just that this wall is moving because of the way the roof has not been tied at this level here. So the roof needs to be redesigned with a tie across there, and then that tie can be used to support proper plasterboard ceiling that will be fire rated. So I also drew the other section here, which is through the living room or through the hallway, because there's the front door. There are quite substantial timber joists here. These substantial timber joists here, which are, let's say, they're 175 deep by 50 at 600 centers. So this area must have been used for storage. Now this will probably help restrain the wall partially, this timber here, but it's not restraining it because it's still moving. You see, generally what you would have to do in order to tie the roof to the floor is this timber should be, let's say, high enough so that it can tie directly into this timber. At the minute, these joists are just built into the wall, and the rafter sits on the wall, so they're not tied together, so the roof can still put a pressure and move the wall outward, and that's what's happening. So when you're redoing this, or when you're doing the renovations, you'll have to raise the ceiling anyway, because it's 2.25 from floor to ceiling, and you need 2.4 minimum to comply with building regulations. So you'll be moving up your joists in any case. But what I would do is I would move the joists up to this level, so that the rafter has a proper tie, and then that will again stop the outward movement of the wall. And once the roof is constructed properly, the walls can be retained, and there's no need to demolish them. They can be retained, and the movement should stop once that wall has been tied. So again, I've shown there, that's your hollow block wall there for your extension, and that's just got a timber roof on it. So this wall hasn't moved, but as I say, it's probably because it's being restrained by the extension. Okay, let's move onward. Now, this video here is actually getting a little bit long, but I'm just going to point out here, now it's difficult to see it here in this photograph because the photograph's two-dimensional, and you can't really see movement like this if you're not in it. If you're not on site looking at it in 3 dimensions, you can't really see it properly from 2 dimensions. But the center of this wall here has moved outward in this direction, so it's leaned out, and that's basically has leaned out slowly over the years. It's leaned out because the roof is putting pressure on it, so that has to be stopped, so that it's not moving. Now it can be retained, but the movement just has to be stopped. So if I go into, this is the internal concrete wall that I talked about, the poured concrete wall. It's a bit blurry, you can't really see it there. So that was poured and shuttered, that concrete wall, and that's a close-up of it there. You can see that poured concrete wall. The staining here is just from the use of the chimney. That often happens. You get soot and different, materials from the use of the fire just penetrating through the wall, and these walls are often very stained, but they're still stable and sound. And the only other thing I wanted to just show you here before I finish this particular video is that's the gable wall there, the internal gable wall there, the poured concrete gable wall. Or yeah, well, it's like, I say gable, it's an internal wall, but it's a sloped, that's for the chimney. This is the front wall here. You can see the stone. That's the front stone wall. And since this wall has been poured, you can see a large gap has been created here between this wall and this wall, basically because the roof is putting a horizontal pressure pushing this wall out. So that gap is probably widening, you know, a little bit every year. So that's the movement. Again, you can see it up there in the chimney. So I'm going to stop this video here, and I'll continue on then.